Good morning, students. In this class, we will discuss about the N-gram language models. Already we discussed about the edit distance method for the spell correction. In this N-gram model, it's mainly used to predict the future words in the sentence. When you are typing the contents in the WhatsApp, you might have referred, suppose you are going to type computer, means automatically it will suggest the next word as science and next is engineering. Instead of computer programming or computer class, it will subject computer science and engineering. Why? We often use the word computer science and engineering. So from this entire corpus, it will check the probability of the word. Whichever word is having the higher priority, that is taken, that is suggested to the user. So based on the probability, the corpus, from the corpus, the words are suggested, means that is called as the predicted future words by using the probabilistic technique. The N-gram technique is also one kind of probabilistic technique. For example, consider Alex swallowed the large grain. 4 options are there: frog, mountain, car, and pill. Which one will be selected? We know that obviously pill will be selected. Why? Means that is having some semantic meaning compared to other things. So when you are going to predict the future words, you will concentrate on some things. First one is the domain knowledge, syntactic knowledge, and lexical knowledge. Domain knowledge in the sense which domain you are going to use that word. That is also very, very important. So that is what called as the domain knowledge. For example, I am telling you that I am going to bank. What you will think? I am going to bank for transfer money or withdraw the money. But efficient man is telling you that I am going to bank. That means you will think about the river bank. It depends upon the domain of the work. And next one is syntactic. Syntactic means the chicken is ready to eat. It means that the chicken is available here when you see this chicken. Whether this chicken is ready to eat? No. We will ask by the meaningful thing, we'll think that a chicken, whether it may be a grilled chicken or it may be a fried chicken or something that is ready to eat. That's the meaning of synthetically you are thinking like that. Same manner, lexical knowledge based on the words, previous and next words also we will predict the future words. This is generally done by the user. But for the computer, we will train them, we will teach them to predict the next word. How it can be done? That will be discussed in this topic. Consider the context sensitive spelling correction. This N-gram technique is also used for predicting the words as well as context sensitive spelling correction. Consider the office is about 15 minutes from my house. When you consider the word MINUETS, that's also available in the dictionary. The meaning of this one is a slow, graceful dance. Is it fit to that location? Sometimes it may also fit. To avoid this confusion, we will check the probability of the particular sentence from the corpus. Corpus means set of sentences. When you are checking the probability, we know that obviously minutes, MINUTS, that minutes having the higher probability compared to this one. So the machine will automatically select MINUTS in the error correction instead of MINUTS. For example, I am telling you that I'll tell you, I am coming to your class. Okay, I am coming to your class. So in that situation, I am coming to your class. Means automatically you think that I am coming to your class. Okay, fine. Now I am telling you, I am coming to take class. I am coming to take class. Or in the speech recognition, I am telling you, I am coming to take class. What class you will think? Whether CLASS or GLAS? Two options are there, no? So which one will be taken? Based on the probability, I am telling you, I am coming to your class. Automatically coming to take glass. Okay. Automatically you'll be thinking that take, two options are there. Take glass or class. Two options are there. I am telling you I am coming to take class. Obviously you will select the second class. Why you are selecting the second class? Your probability of the class is high compared to glass. In your class, I won't say that I am coming to take the glass from your class. It's not possible. Instead, always I am coming to take the class only. In this situation, when you consider the probability, what do you mean by the probability? Frequency of occurring of the word is high for class. So automatically you will think this is class. Same manner, we will give the we will generate algorithm to think like that. That is one kind of algorithm is the n-gram algorithm. There are so many language models are there. Most of the language models, we are taking the next sentences or next words based on the probability. Some will consider how, when you are typing how, what will be the next consecutive words. It may be are you, do you, do, old are you. So many things are how are you, how do you do, how old are you. When you consider all these things, generally we are using the word how are you, no? Actually, we are always asking how are you. Then the probability of how are you is high compared to how do you do and how old are you. Hence, this how are you is suggested to you. This one is mainly used for the speech recognition, machine translation, spell correction, etc. One n-gram language model is also a kind of language model. Here we can predict the probability of the given n-gram with any sequence of words in the language. Already we discussed about bigram, unigram, n-gram, trigram, etc. What do you mean by n-gram? If the terms are combined based on the sequence, that is called as gram. For example, consider a single word. Hi, how are you? Hi, how are you? If I am going to split it into a unigram, what all are the words available here? Hi is the first word, how is the second word, or is next word, and you is the next word. So 4 words are there. That is the unigram splitation. What do you mean by bigram? 2 words are combined in a time means that is called as the bigram. For example, hi, how is first taken, then how are is then taken, or you is next taken. So these are the bigram words. What do you mean by trigram? Trigram means 3 words. 3 words are selected ones. Hi, how are, then how are you? This is called as the trigram. So in the unigram means size of this word is 1. Bigram means size of the words. Number of words selected at an instance is 2. Trigram means number of words selected at an instance is 3. To divide it into that, when you are doing the calculations and when you are doing the program with some algorithms, then we will include the start symbol as well as the end symbol. Don't forget that in the problems, we should include the start symbol and the end symbol. For example, in this one, if you want to divide it into the bigram, first include the start symbol. It may be of any form, and the end symbol. Okay, start symbol as well as the end symbol. So bigram means how you divide it into bigram. First, for dividing it into a bigram, 2 words are taken at a time. So, this one, 2 words. So, 2 words means what are the first 2 words? The dog is the first word. So, first you should select the dog. So, this one and that one. The. What's the next word? The and the dog. So, the dog. What's the next one? Dog and the smelt. So, dog and smelt. Then smelled like, shrunk, a shrunk, a shrunk. And n parameter is also there, shrunk this. So this is the bigram representation of the given sentence. If it is a trigram representation, how will you represent this one? Trigram representation means this one. That is, these 3 words are taken first. So the dog. And then these 3 words. The dog smelled. The dog smelled. Then these 3 words smelled like a. So dog smelled like a. Like that, 3 words are combined together to form the sentence. Generally, how to predict the next word means based on the likelihood. X, suppose X acquiring the text and Y is the next word. Then with the help of occurrence, how many times this Y is occurrence in combined with X, based on the likelihood only, we are going to predict that. For example, in our class, friends are there. If he is there, automatically we are thinking that friend is also nearer to him. That is the manner we will predict the students. Easily you can predict the students. Same manner from that by using the likelihood concept. Because how can I predict? Probably this person is there, his friend is also sitting nearer to him. Same manner, this one is there, probably it may be available there. That's the concept of the prediction. For predicting this one, I told you the probability is important. So predict the probability of the sentence, you should predict the probability of each and every word of the sentence. Word 1, word 2, word 3, up to n number sentence, n word sentence means we will predict the word by using the n different words of the particular sentence. Consider this one. Its water is so transparent that so transparent that what will be the next word? Generally, that means that, that. There is the next possible word. A is also possible, and generally, in general, we are using there only. So here we should predict the probability of the occurring there in the particular sentence. We will see this with the example. You remember this formula? In the N-gram model, we are using the chain rule to predict. Chain rule. Next possibilities are checked to find the probability of each and every sentence. And also we are dealing with the maximum likelihood estimation. This is the formula to find the probability. Probability can be defined as probability of Wn by Wn minus 1 equal to count of Wn minus 1 into Wn divided by count of Wn minus 1. That is probability of this word. This one a current word. Probability of this word divided by the previous word equal to count of the combination of previous word and this word divided by count of the previous word. This is the way you should find the probability. Whichever is having the higher probability, that will be appear in the next to the particular word. I'll discuss this some example. Consider bigram method. In the bigram method, at a time we are taking two words, right? So probability of the second word by first word equal to count of the combination of first and second word divided by count of combination of the first word. That is, for example, consider these are the set of sentences. Consider these are the set of sentences used in our corpus. Here, I am going to find the probability of each and every word. We know that probability of the second word by first word equal to the count of first and second word divided by count of first word. So now I am going to, this is the bigram method. We are dealing only with the bigram method. Bigram method means take two tokens at a time. Tokens mean two consequent words at a time. So now consider these two. Remember that if the this is not given, the end symbol and the start symbol is not given, then you should include the end symbol and start symbol also. Generally, the S is included in the start and this one is included in the end. So first I will take the first two tokens. What are the first two tokens? This start symbol as well as I. I'm going to find the probability of these two. So yes, and I first two symbols, I'm going to find the probability. To find the probability of these two symbols, I'll write second divided by first, right? So probability of second one divided by first one. Second one is I divided by probability of S. I divided by S. So to find this one in a easy manner, first to find the probability of, that is the occurrence of, count of, number of times. Count means number of times. Number of times the availability of the particular token. Here this token is starting symbol. So number of times in the entire corpus, test the number of times S is available. How many number of times S is available? We check that one. How many number of times S is available means the starting symbol is available. 1, 2, 3. 3 times the starting symbol is available. These are the end symbols. So give that in the denominator. Okay. Take the count of this one and that is given here. Then dollar followed by I. Here two letters, the first word and the second word. Count of the first word, that's given here. Count of first word is this starting symbol. Count of starting symbol is 3. And second is count of first word followed by the second word. So this starting symbol followed by I. How many times starting symbol followed by I is available? Check that. Starting symbol followed by I is available here. And starting symbol followed by available here 2 times. So 2 by 3. This is the probability. The value is 0.67. Now you say it's for the probability of Sam and S. We can find it for anything. Now I'll find it for Sam and S. Sam and S. That is the second word is Sam. For here, for this one, I am going to find the probability Sam and S. So I'll write probability of second word divided by first word. The second word is Sam. Sam divided by the starting symbol. How will you find this? In the denominator, find the number of times this starting symbol is available and put a number of times starting symbol 1, 2, 3. So write 3 here and starting symbol followed by Sam. These two words.
This is the bigram method. So we should find the probability of the combination of two words here. Then this is yes followed by Sam. How many times it's available? How many times it's available? Starting symbol followed by Sam is available only one. Right? So 1 by 3. This is the probability. Same manner, I'll find it for I am. Take this I am. So am, probability of am by I, probability of am by I. How to find that? First find the number of occurrence or count of I in the entire corpus, not in the single sentence. Find the probability of or the count of I in the entire corpus. How many I's are available here? The first sentence 1 I is there, second sentence 1 I, third sentence 1 I. So totally 3 I's are there. Okay, write it in the denominator, and here there are 3 I's and followed by I am. Check. How many times I am is available? Yes, 2 times. So here one I am is there. Here one I am is there, and here one I am is there. So write this is 2. This is the probability. Like this one, I do. I'll find it for I do. How you write? Probability of do divided by I. That is equal to find how many number of times the I is available. I is available 3 times. 1, 2, 3. So I is available 3 times. And here I do, take I do, combination of I do is a bigram, combination of I do. How many times I do is available? Only 1 time I do is available. So it's 1 by 3. Suppose I am taking like green means green divided by like. Probability of, if I want to find this one means probability of like divided green divided by like, or not like. I'll find like, not like means like divided by not. So how many times not is available? Only 1 time. And not like is available only 1 time. So 1 by 1, the probability is equal to 1. Only 1 time it's available. So based on that, find the probability and do the calculation. Okay. One more example, estimate the likelihood of the sentence I want to eat Chinese food. How will you find this one? First, we should include the start symbol as well as the end symbol. Here we should include the start symbol and include the end symbol also, whatever be the sentence. Then divide it into bigram. So probability of, to find this one, I want to eat Chinese food. To find this one, how will you write? This one first, right here, probability of this I want to eat Chinese food. So here I have added the start symbol and the end symbol. First take first two. First two means second word divided by first word, no? Probability of I divided by the start symbol. I divided by the start symbol. Then probability of want divided by I. Second and third symbols now I have taken want divided by I. Then probability of two and want. Probability of two to want. Then probability of eat and two. Eat divided by two. Then probability of Chinese divided by eat. Food divided by Chinese. That is the second letter, probability of the second letter divided by the first word. Second word by first word. Okay, that is equal to count of the combination of first two words divided by the second word. Check this one. This is end. So probability of end divided by food. This manner you should divide this sentences and find the probability of each and every sentence. Then multiply all these things, you will get the entire probability of the particular sentence in the corpus. Consider this one. I want to eat British food. Here also add start and end. End is missing here. Probability of end should also be added here. End by food, that should also be added here. So I by start, want by I, eat by two, then British by eat, food by British, food by the end symbol. Find all the probabilities. The probabilities are given in the already given in the table itself, because by calculating the probability from entire website or entire book or entire corpus, that is given. From that we can take that one, probability of I/start. That is, if you are finding the probability, that will be given start I. Okay, start I. Start symbol and I. Start symbol and I, the probability is 0.25. Similarly, here you are calculating for I want. Okay, you are calculating the sentence for I want. For this only, this one, probability of I want. I want is here, that is 0.32. Take that one. Then want to, probability of want to. This is the formula. So want to is 0.65. So 0.65 is added here. Then to eat, where it is to eat 0.26. Then eat British, where it is eat British. British. Eat British is missing here, no? Into British food. Eat British, I think this for this one 0.001, that's missing here. Then British food, that is 0.60. So 0.60. All the probabilities are taken from the table and that is multiplied. Here, N-gram models can be trained by counting and normalization of this values. Okay, if the longer the sequences, then less likelihood are there. If small sentences, more likelihood are there. That is here we checked for a single sentence how to find the probability. Now we were going to check the probability between the given sentences from the corpus and the test sentence. Here this is one question. This kind of question can be asked for the examination also. Consider this one. Consider the training corpus. From this one, training is performed and by using a given sentence, we'll test the probability of the given sentence. Consider the training corpus with 4 sentences. What are the sentences? Everything must be begin and end with the starting and end state. If it is given, fine. If it is not given, then you should include the starting state as well as starting symbol yes, as well as the end symbol /s. Okay. The sentences given are 3 friends, Samar, Akbar, and Anthony are reading book. This is the first sentence. If it is given in the paragraph, then divide it into sentence and give the delimiters. That is, give the starting and the end symbols. Second sentence is Amar is reading web technology. Third sentence, Akbar is reading a detective book. Fourth sentence, Anthony is reading a book by Rahman. Now, we are going to estimate the bigraph probability of this test sentence. The sentence given is Amar is reading a book. For this one, by using the given corpus, what will be the test probability? We are going to analyze that. Consider this one. These are the given sentences, that is the test sentences, and our training sentence is Amar is reading a book. For Amar is reading a book, I am going to find the probability. For finding the probability, say take the words one by one. Okay, this is the bigram model. So take 2 words at a time. Word 2 divided by word 1. Okay, probability of word 2 divided by word 1 equal to count of word 1, 2 divided by word 2. So first take this 2. Right? Is to take these 2. These 2. So probability of word 2 by word 1, right? Probability of Amar divided by this one. Probability of Amar divided by starting symbol. That is, then we'll count. To perform it in a easy manner, first count this one. Fine. First count number of starting symbol. How many starting symbols are there in the test case? Don't forget that you are going to find it from the test case. How many symbols are there? Start symbols. How many start symbols are there? 4 start symbols are there. What all are the start? 1, 2, 3, 4. 4 start symbols are there. So number count of this S is equal to start symbol equal to 4. And then find start symbol followed by Amar. This is the first word and this is the second word. How many times it can be followed? Okay, bigram manner, how it can be followed. So you are going to find how many times yes, Amar is there. How many times yes, Amar is there in the corpus? Only in the test corpus. Yes, Amar is available only 1 time. So yes, Amar is here in only 1 time in the test corpus. So only the value is 1 by 4. You are calculating the value, that is 0.25. Okay, next. What is the next step? Take the next 2 words. What are the next 2 words? Next 2 words are Amar is. Correct? Amar is. So now we are taking Amar is. Amar is. Okay, what's the second word? Is. First word, Amar. So we will find the probability of is divided by Amar. Okay, yeah, is divided by Amar. First, what we should do? Find the number of occurrences or count of the word Amar. Count the number of words in the Amar from the test. This is the training. From the training. This is the training corpus. From the training corpus, count the number of times. How many number of times Amar is available? We'll check. How many number of times Amar is available? Check. Amar, here Amar is available. Here also Amar is available. How many number of times? 2. So that's given here. 2 times Amar is available here. And how many number of time Amar is? So we are going to find it for Amar is, right? How many number of time Amar is available? In the second statement, Amar is here. So 1 time Amar is available. 1 by 2 equal to 0.5. Same manner, take the next set of things. Is reading. Is reading means, right? It's for is reading. Is reading means how will you find the probability? Probability of reading divided by is. So first you should find how many number of times is available. Go and check in the corpus how many number of times is available. We'll mark it to the here is available, here is available, and here also is available. How many number of times? 3 times is available. So is available 3 times. Then write is reading. Okay, is reading. How many times is reading is available? Check it. Is reading. Here one is reading is there. Here one is reading is there. Here also one is reading is there. 3 times is reading is available. So this is this 3. So 3 by 3 equal to 1. The next one is reading. Next take reading. So next take reading. Probability of second word divided by first word. So probability of A. A is the second word and reading is the first word. A divided by reading. Now what we are going to check? How many times reading is available. Go and check how many times this reading is available. How many times reading is available? Here reading is there. Here reading is there. And here also reading is there. So reading is available 4 times. Okay. Reading is available 4 times. Then reading a book. Reading a book is available 1 and 2 times. So reading a book is available 2 times. Then 2 by 4 equal to 0.5. Same manner, find it for the next step, a book. Take a book. So I'll find probability of book divided by A. Find how many times A is available. A is available 2 times. A is available reading a book. Here A is there. Here also A is there. A is available in 2 times. So take this A 2 times and book. Book is also available 1 A book. This is reading book. This is only reading a book. Reading a book is available only 1 time. Okay. First find the count of this A. Then find the count of A book combinedly. Because by graph 2 words at a time. Then last one is book is book and end symbol. So probability of end symbol by book. Find the probability of book. We know that the probability of book is how many times book is available? 3 times book is there. 1, 2, and 3. 3 times book is there. And the probability of book followed by the end symbol. Book followed by the end symbol, the probability is 2. So 2 by 3 is 0.75. Now multiply all these values, you will get one answer. This is what the probability of Amar is reading a book in the particular corpus. Okay. So next word will be suggested. In this one, if you are going to suggest the word, which sentence is having higher priority, that will be suggested to you. When you are typing the word in this mail and all Gmail, suppose your candidate, writing candidate means automatically it will suggest name. Suppose candidate number is there, candidate color, candidate address, anything is possible. First, but the probability compared to that sentence, the probability for name is high. So that is displayed. So in this manner, the words or the sentences are suggested to the user. This method is called as N-gram method. You practice this one also. Okay, thank you.